experiences of bug beetle damage mapping at different resolutions in Finland. So just a few words about myself. So I have been working in FGI since 2014 in the group of EIA, and I actually started this bug beetle damage mapping already in the beginning of my academic career, because I started to work in FGI and they gave me a chance to work with this topic and write my master thesis about it. In 2014, I started work with the topic, and my master thesis was then about the mapping of forest insect damage using hyperspectral stereoscopic aerial images. And after the master, I then started to be as a PhD student, and then 2021 I graduated from PhD from Aalto University, and there the bug beetle mapping was one application, but we were also working with the agricultural topics. So keywords to me: drones, agriculture, forest health, hyperspectral imaging, machine learning, and what I'm interested is actually to see the applications, how they are working, and then the field work, and also the drone piloting. I have been doing a lot of drone piloting. I think last summer was like more than 100 flights in different kind of projects. Okay, so about today's presentation, so I will give some background about the topic resolutions, and then drones and sensors and pipelines. Eija was a little bit introducing this already, but I have a little bit different point of view for them. Then I will show some 3 case studies, and then focus how the different resolutions is affecting to the results, and then we will have also some conclusions then in the end. Yeah, so I think everybody know what the spatial resolutions means, but just something about our drones and platforms, because it's one aspect what is affecting to the spatial resolution, the flying height and etc. There's also other things, of course. Yeah, so we have been using drones for this topic since 2013. There is some evolving drones. First there was this kind of smaller drones, and it was like kind of research drones, so we were building in our group. But then lately we have been also starting to use the commercial drones. And here is just some examples of the spatial resolution. So here's if you look at the Sentinel images, it's like 10 meter the resolution compared to from there you can see so well the individual trees. And if you go even more detail, this is from the aircraft actually. So here we can already see the individual trees, but from the drone images, if your spectral resolution or spatial resolution is better than 10 centimeters, you can even start to see the different branches. Yeah, and about the spectral resolution, so it's totally related to the sensors, what we can use. So we have been using many kind of different sensors. Hyperspectral sensors, we have been using this sequential frame inframeter based sensor for a long time, and the spectral characteristics are here. So it's from 500 to 900 nanometers. It can collect like 20 to 50 bands depending on the settings, and then the full width half maximum is around here. Actually this is also like demonstrated here, like how it looks then in the spectra. So here is this hyperspectral sequential frame camera, and then also the multispectral camera here in the up. So with multispectral you can get also data from all of this area, but then just smaller snaps from them. Yes, then we have also the bus-prone camera, but Eija was already presenting earlier, so in this presentation I will not talk about these sensors. Okay, yeah, then this is the workflow. Just Eija basically already presented it, but just to remember that we need of course, the remote sensing data to do comparison, and then also the ground truth, the locations, and then the variables or the observation what in the forest. So when we go through the process, then we can compare different kind of cameras and so on, how they can, which kind of results they can give to us. Yes, so I will have here like 3 case studies where we have been focusing to different aspects of the resolution. And let's start with the first one. So here we have spatial resolution, and we were using UAV and then aircraft, and somehow we were also comparing the spectral resolution. So here the data was collected by Päivi Lyytikäinen-Sarma and the group, and what we were using here as a ground truth was actually the ground color. So there was different visual inspections, like is it looking green, yellow, or then if it's turning to brown, or is it already dead. So there was also collected different other symptoms, but in this work we trust of these. Yeah, and here is some information about the specification about the drone data, but I will not go to details of them now. And which kind of results then we get in the end. So here we actually compared the results when we were using like 3 different vegetation indices. So we didn't state this in our original article, but we could now think that since there was only 3 indices and the data was actually from 5 different bands, so we could think that it could be simulation of multispectral camera. And then we compared the results with the full spectra, and which kind of results we here get. Actually we get overall accuracy of same from both, but then if we look the accuracies of different classes, so from the full spectra we get the dead and infested trees higher, but then in the indices we get the healthy class higher. So at least we think that the infested actually is the most important class to be mapped, so it was better in the full spectrum. And then we have also the aircraft data from there. So here you can see the spectral difference. This is the 50 centimeter spectral difference spatial resolution, and then here is the 9 centimeters. So here we can see much better to even the branches, but also into this 50 centimeters data you can see the separate trees here. And what we get from here, so the overall accuracy using the UAV data was 91%, and then with the aircraft it was 73%. So we get better results with higher accuracy. The difference was not very big, but there was a difference. And then one other interesting test what we did during this experiment was that we were also testing if we can train the aircraft data using the drone spectra. So if we can like transfer the drone spectra that we could use as a reference for the aircraft, and we get quite nice results also with this. Yeah, here we can also see how the spectra, average spectra of the different classes were looking. This was the first case. So let's go to the next case. This is place where this was done is called Nuuksio. So here we have even more the resolution comparisons. In context of spatial resolution, we were using the UAV, but also some leaf measurements. And then spectrally, we were again comparing the multispectral and hyperspectral, and then we had also time series, so we had kind of temporal resolution aspect as well here. In this case, the field inventory was done by Luke, and there was found 28 bark beetle trunk symptoms, and in this area we had also other biotic like stress for the spruces, root rot. So it was not only bark beetle, there was also other problem there in the area. So there was also that, and then there was healthy trees, and then in the end there was one dead tree. Actually, it's here. So we were actually expecting that there could be happening more effect for the bark beetle, but it was quite mild actually in the end. Yeah, so here we collected time series with the hyperspectral and multispectral. So we started in the end of July and then finished in the October. And this multispectral and hyperspectral data was collected in every time. Yeah, and then we had also leaf spectrometer measurements. So here we would like to see that and measure the needle spectra at high spectral accuracy as possible in controlled conditions, and to see if we can see from there some spectral prospects about the topic. So we take the samples branches as high as possible from here, and then we measure them just after in our field laboratory here. And here is some visual time series of a dying spruce. So in the beginning of our time series collection, so end of July, it was still looking very healthy, and then after 1 month it was looking still quite healthy, but then after 1 week here it started to get a little bit more yellow, and then in the end of the data collection it was totally dead already. Here is just as a reference one other tree that was healthy, so how it was looking in the same conditions, so it was not dying at all. And here is then how these two same spruces what I just showed, how they spectrally behave when we look them from the hyperspectral drone images. So here in the left is the dying spruce, and then here is the healthy spruce. And so the spectral curves are here starting from the August, and then they are going until to the October. So if we start to look here, the blue one, we will see still quite healthy spectra here. Also after 1 week, it's still quite healthy, but then in the 1 week it starts to have a lot of differences here in the red part of the spectra. So actually 1 week the difference was quite huge in the spectra, as we also see from the images here. So only with 1 week difference it starts to turn very fast to yellow. And then, yeah, in the end it was already totally dead, so then the spectra looks like this. And if we compare this to the healthy spruce, so was very stable. So at least in this case, the first signals that it will start to die was in here in the red and red edge spectral range. And then the same trees when we compare the needle measurements. And this is the first derivative of the spectra. So basically we will find the same like spectral bands where the first signals were visible. Here we did show that we collected the new needles and old needles spectra, and noticed that actually the new needles the change is faster. So here we can see that from this one from the new needles from the last measurement, so it was already totally die, and it started to die already here. And here as a reference again that the one healthy spruce, so it was quite stable the spectra during our measurements. So this was what I showed, it was like 3 against 3, so there was only 2 trees in comparison. So here then I mentioned in the beginning that we had like 28 healthy trees and 28 trees where was some kind of signs of bark beetle. And then here we have plotted like how the average spectra is evolving during our data collection. And the difference was not so big, probably because of the bark beetle effect was very mild still in the most of the trees. But we can here see, so the gray lines are like indicating where the spectra is statistically different. So we see more like changes in the visual range than in the near range, actually, in this case. And then we also performed the random forest machine learning model. We were trying to classify the bark beetle and healthy trees, and then there was also the root rot class, and then we compare the multi and hyperspectral cameras data, how we could compare them, and we get results like that hyperspectral was mostly outperforming the multispectral, but some cases also was actually opposite. Here was opposite, but we need to remember that here was quite low amount of data, and especially this root rot class was then mixing to other classes if we are looking the confusion matrix. Yeah, this is just a picture that there was not happening so much damage that we were expecting. So the one dying tree was actually fallen down when we again monitored after the winter here, but otherwise it was the spruce were strong enough, so they put actually the bark beetles out. Then we have still one case, and this is from Ruokolahti, and here we are comparing UAV and satellite, so spatial resolution comparison. So we have been collecting here drone data already since 2015. We have collecting data 15, 16, 19, 20, and 21, and there has been like 3 or 4 different areas here. 2 of them are protected areas where was actually a lot of storm was like falling down the trees, and so they were like already a lot of the dead trees, and 2 other areas were then more starting symptoms. And here we have the ground truth, so it was collected again by Päivi and that group. And here we used different kind of tree health index, what we were using before, for example this Lahti data, where we trust only the color symptoms, but here we were combining to the same index also the racing flows and holes, and bark, so trunk symptoms, but we get more weight for these 2 symptoms. So we had kind of like continuous health index then, and then in the end we were giving like scores in which ways they will be after we evaluate this index. So here, if you want to understand the scale, so always the number 1 is mild, so even it's a smaller number, so more healthy the tree is. And here is results for the year 2019 for the multispectral drone data. And yeah, here in the down we were comparing like vegetation indices and specular features. So with the specular features we get quite nice R2 values. RMSE was like 2.7, so it means that maybe some trees can be like mixed between close classes, but it can't go like to the dead to the healthy, but here it can have some kind of mixtures. Yeah, here we can also see that this Ryhmälehdonmäki and Murtomäki were more healthy comparing to these 2 where was more dead than declined trees already. But then we wanted to also check how we could, if we can use the optical satellite data to monitor bark beetle damage in Finnish conditions. So we perform this kind of questions that how can drone data be utilized together with satellite imagery, and then does the utilization of drone images improve satellite-based analysis. So we were thinking that we could take advantages of both data sources. So then here is the kind of method how we were then doing this. So first of all we had that kind of 3 healthy map from the drone images from the previous slide what I showed here. So we have the data here in the first one, so we have already this. And then in the next phase we were doing the healthy maps for the whole drone area. And then we were thinking that we could use this data to make training pixels for the Sentinel. So then we did so that we calculated the average health class of each tree for like pixel wise, like which trees are in 1 pixel, so then we get the training for it. And then in the end, then we could use this, we could test if this model will work well in the whole area. And here is some visual results what we get from there. So here in the left, this is like the ground truth pixels from drone data. And here in the middle then is that approach what we was just trying. So we get, if we compare these two, they looks quite similar. And then we would like to show how what was like benefit to use drone data. So with the drone data we get actually almost 11,000 reference pixels for the machine learning. But if we would use only the original plots, original ground truth data what was collected, so we would have only like 89 reference pixels. And when we applied that model, we get quite bad looking results if we compare our ground truth here. And actually then what was if we compare this pixel wise here, so the overall accuracy was about 90%, and the kappa value was also relatively high. In this next slide there will be more details about this confusion matrix. So here we can see that mostly the confusion was happening here in the slightly declined and declined classes. So why we actually called here slightly declined? We are not anymore trying to say that it's green attack, because now we understand that there in 1 pixel it can go to the slightly declined or declined class if there is both dead and healthy trees. So in the average it can be still in the middle class. So we will not say that it's green attack, but there is some kind of declination going on. Yes, so here's again similar things like how much there's different like what is the distribution of different classes in the different areas. Then we were also looking the time series from the Sentinel pixels during the summer months of 2019. So here is actually the healthy pixels and then the dead pixels. So in the April there was some kind of difference already. Actually they were already that time statistically different, so the bars are again indicating this. In the June there was still, it looks quite similar, but in the August the difference was higher, and this was quite expected results, that the difference will be bigger in the late summer. Yep, here is the reference list, what we have been, based on what I have been presenting, and then last some conclusions. So we can conclude that the results usually improves when analysis is possible to perform at individual tree level in comparison to pixel or kind of aerial-based level. And especially in Finland, the bark beetle infestations are rarely appear in the cluster of trees, what is maybe case here in Central Europe. Instead, the infested trees are scattered around the large area. So that's why in Finnish conditions, the individual tree detection would be maybe the most accurate way to do the analysis. And then about the spectral resolution, so we have noticed that the most accurate results can be achieved using the hyperspectral data. And then we have also noticed that it's actually not so easy to get the data from green attack phase, especially in the natural conditions. What is maybe good for forest owners, but not so good for research if we are putting a lot of efforts to try to find it. But then in some cases the multispectral data can produce also quite sufficient results, especially if we want to classify for the trees to the three classes only: healthy, infested and dead. Yeah, I think that was my presentation. Thank you for your listening.